This video tutorial shows the use of the MMD program for self-attribution. We will do self-attribution for Campylobacter sources, but the same steps can be followed to study self-attribution for other datasets. For instance, you can try self-attribution for the human datasets provided in the MMD package. Self-attribution for a given source is a cross-validation strategy that consists in selecting a random fraction of genotypes from the source and pretend that they are from a known origin. The idea is to attribute the selected genotypes to sources. The MMD program repeats the procedure for self-attribution of all the sources. We start by setting the parameters needed for self-attribution in the MMD input file. Several of the entries in this file are the same as for source attribution. Here, we just show the entries that are specific for self-attribution. The rest will not be modified with respect to tutorial 1. An important entry for self-attribution is the second line of the file, which we must set to SA. The value specified for the name of the population to be attributed is irrelevant for the self-attribution, and the program will not use it. Another parameter specific to self-attribution is a fraction of genotypes selected as unknown. In this example, we select 50% from each source. The Q-quantile can be set to a particular value, or we can specify a range of values to optimize the probability of correct self-attribution. In this example, we'll optimize the self-attribution probability for each source, and the value specified in this line will be NOR. The settings to specify an interval for the Q-quantile are introduced in the next 4 lines. The first line should be set to Y to tell the program that we want to optimize the self-attribution probability. The next 2 entries specify the minimum and maximum values of the Q-quantile to be explored. Here we explore the whole range between 0 and 1. Finally, we set the program to explore 1000 values between 0 and 1. The rest of parameters can stay as they were for the source attribution example in tutorial 1. The input file is now ready, and we can run the code by double-clicking on the Run MMD BAT file. This starts self-attribution for all the sources, one by one. The program window shows the files created in the project folder after self-attribution for each source, and once the calculation has finished for all the sources, it shows the files that summarize the self-attribution to all the sources. The number of loci used for the analysis is explicitly indicated in these files to facilitate a possible analysis of the self-attribution efficiency as a function of the number of loci. Files PS and PUS are created for each source, and they are analogous to those created for source attribution. The file starting poplist SA is only created for self-attribution and shows the list of populations of each genotype in the same order as in the first column of the genotypes data file. As can be seen, the list shows the genotypes used as unknown in the run. In this example, half of the wild bird genotypes have been set as unknown. A 2-page PDF file is created for each source. Page 1 in this file shows the probability of attribution of the selected genotypes to each source. Page 2 shows a plot of the probability of attribution to the self-attributed source as a function of the Q-quantile. In this particular example, the maximum probability of correct self-attribution is observed for a Q-quantile of 0.001. This value is indicated in the name of the attribution files. The data corresponding to this plot is stored in a file starting with P versus Q. The file starting with probability correct summarizes the statistics of the probability of correct self-attribution for each source. The format is similar to the PS files. The second column shows the mean of the probability of correct self-attribution obtained by averaging over all the attributed genotypes. Columns 3 to 5 show measures of dispersion. The last row shows the average of these quantities over sources. Finally, a one-page PDF file was generated with a bar chart for the probability of correct self-attribution for each source.